When the collected water from Alaska and the Yukon is brought south through the Rocky Mountain Trench, it enters the Columbia River Basin and the beginning of the transfer section of NAWAPA. This system lifts the water up into the high elevations of the Great Basin. Largely centered in Idaho and Montana, the lifting system brings the water south into Utah and Nevada, where it can then be distributed throughout the rest of the Southwest. Since the distribution networks are at an elevation of over 5,000 feet above sea level, and we are starting at under 3,000 feet from when we left the Rocky Mountain Trench, the most dense and powerful pumping component of the entire NAWAPA system is centered here. Imagine the Alaskan water arriving from the north will be lifted to over twice the height from which it originated. This component is known as the sawtooth lift system. This incredible feat of lifting tens of millions of acre-feet of yearly water flow up thousands of feet in elevation is accomplished by using dams and pump systems to reverse the flow of a series of rivers in the Sawtooth Mountains. Then, these rivers are to be connected with large tunnels. Starting at an elevation of 2,800 feet, the water will reach 5,250 feet at its height. From the Clearwater Reservoir, the water is lifted into the Lochsaw Reservoir. Then a tunnel will connect the flow into the Selway River's 3 reservoirs, which will be connected by 2 pump lifts. From here, a tunnel takes the water into the Salmon River, where 3 lifts connect 4 reservoirs and bring the water to the Sawtooth Reservoir at 5,250 feet. Then the water will flow through a tunnel 50 miles in length and 100 feet in diameter, feeding into the Great Basin Waterway and the entire distribution system throughout the rest of the continent. Also, additional water catchment systems add water into the Sawtooth system from the east and from the west. So what we are doing here is basically running a major river 2,500 feet up a mountain range continuously year-round. This will require a huge amount of electricity, 26,000 megawatts, or 7.5 times the entire current electricity consumption of the state of Idaho. The original 1964 Parsons design runs the 26-gigawatt pumping system purely from hydroelectric power, generated by the NAWAPA system itself. In fact, the original NAWAPA design would provide a net surplus of hydroelectric power. However, our implementing this program 50 years after the initial designs means that we can take advantage of the growth of the nuclear age. This is the most dense concentration of activity in the entire NAWAPA system, and it is appropriate to utilize the most powerful energy source available for this project. A specially designed system of advanced nuclear reactors will not only provide the power for the lifts, but because we will design the system to provide large amounts of excess power as backup for safety and maintenance requirements, that excess power will drive a large complex of industries in the surrounding region. Like Franklin Roosevelt's Tennessee Valley Authority, this is more than just a water project, but mankind creating a new platform of preconditions which will determine what new levels of productivity we can achieve. The transfer function ends where the Sawtooth Mountains lead into the Great Basin, through the Sawtooth Tunnel, from which the water will be distributed to transform desert lands into green gardens of productivity.